In order to perform the experiment, we have to go to the engineering laboratory to get the equipment and materials needed. Set the two towers 2 meters apart and make sure that the receiving antenna is set for horizontal polarization. Make sure that the area surrounding the towers are free from metallic structures. Mount the reflector and dipole in the Yagi boom. Then add the Yagi boom into the dish antenna. The dish antenna should be screwed in the generator mount. And then put the whole setup into the generator. Make sure that the dipole is 30 cm away from the antenna and reflector 3 cm away from the dipole. Using the black cable, plug it into the receiver and generator port of each tower. Using the USB, connect the cable into the generator and to the computer. When all hardware connections are done, turn on the power to the generator and the motor enable switch. The generator antenna should rotate and then stop. And then open the S-File software from the computer and launch the 57200 antenna lab. Choose dish antennas and then choose practical 1. Open the rotor generator controller. Set the motor speed to 18. Set frequency to default 1500 MHz and then press. Make sure that the dish is pointing directly at the receiving antenna. After all these steps, you can now connect the dipole to the generator. Open the radiation pattern plotter and then click plot. Plot again at 1200 MHz and 1800 MHz. So this is the video for the 1200 MHz. Meanwhile, this is for 1800 MHz. Then open the frequency plotter and then click plot. Plot the forward gain over the default frequency range of 1200 MHz to 1800 MHz. And then open the real-time signal level display. And then set the frequency back to 1500 MHz. Now try adjusting the distance of the dipole to the dish and find the optimum position for the dipole. In this, the distance of the dipole to the dish is 30 cm. For the second setup, the distance of the dipole to the dish is 30 cm. Next is the distance of the dipole to the dish is 20 cm. And then the distance of the dipole to the dish is 14 cm.
Figure 5.1 shows the radiation platter at 1500 MHz as the dipole is 36 cm away from the dish antenna. For frequencies of 1200 MHz and 1800 MHz, it can be seen at figures 5.2 and 5.3 respectively. In figure 5.2.1 and 5.3.1, it can be observed that the decibel values at cursor pointed on 0 degrees, which are 38.1 decibels at 1200 MHz and 9.18 decibels at 1500 MHz as per their 180 degrees counterparts at figure 5.2.2 and 5.3.2. The values are 24.8 decibels and 9.45 decibels. At the default frequency value, which is 1500 MHz, the forward gain is displayed using the frequency platter as shown in figure 5.4. Figure 5.5 shows the real-time signal level or the received signal strength with approximate value of 46.5 decibels. A distance from the dipole to the dish at 36 cm, 30 cm, 20 cm, and 14 cm shows at figure 5.6, 5.6.2, and so on using a radiation platter pattern.
This practical allowed the students to explore the properties and mechanisms behind the working principle of a parabolic dish antenna. Parameters of the antenna were varied, such as the operating frequency as well as the antenna's feed mechanism location. A series of tests performed showed that the parabolic dish antenna is a highly directional type of antenna. As the radiation plot showed, the beam width of the antenna appeared to not be greater than 10 degrees. In addition, the radiation plot showed that the RSL is maximum when the antenna directly faces the receiver. However, varying the feed mechanism's distance from the parabolic reflector greatly influences the gain exhibited by the antenna. For this particular antenna, the optimum distance of the feed mechanism's distance to the reflector was discovered to be around 30 cm, where the gain is approximately 48 decibels. Moreover, the particular antenna tested in this experiment appears to dip in performance at 1420 MHz and have a more consistent performance at 1500 MHz to 1800 MHz.
After doing the experiment, do not forget to return the equipment and materials to the engineering laboratory.